So this brings us to stateful versus stateless execution of our simulator or emulator tool. So when we're connecting with the physical world and we're emulating a system, suppose we are accepting control signals. Those control signals would be telling our emulated system to change its behavior. As you change its behavior, it's going to respond to the outside world in different ways. This would be an example of stateful operation because the state of the emulated system changes in response to an external input. Now, this is very important to have because it makes our systems interactive, and that will better replicate the real world as our real world devices are stateful. However, it makes reproducing systems very contextual and state dependent. So if you want to reproduce a particular experiment or example of an emulated system, you would actually need to reproduce all of the context as well, making sure that the state of the emulated system matches the state that you're trying to reproduce. On the other hand, simulator software can run in a stateless format. This means that the simulated system is completely independent from the external world. If you query the simulated system many times with the same query, you should get the same result each time because each simulation run is totally independent from any previous runs. This makes simulators more reproducible, which makes them great for doing things like scientific, like doing science and coming up with scientific results that you can use to inform your system. It's great when your results can be rerun and reproduced, which makes them very convenient for design.